Okay, I had a lot of questions about the chi-square analysis part of your gizmo activity. So I'm going to go through that with you real quick. First of all, just a reminder what chi-square is. It's allowing you to compare observed and expected data, and your expected data comes from your null hypothesis. In this instance, we're comparing mitosis rate in an untreated onion root tip or in untreated cells versus mitosis rate in cells that were treated with caffeine. Your gizmo gave you your untreated data. So this was just kind of your control. These were mitosis rates that you figured out based on just normal cell division with no treatment. Then this data here in the second table, this is showing you the mitosis rate that occurs when you treat the cells with caffeine. The null hypothesis is going to be basically that those two sets of data should be equal. In other words, the null hypothesis would be something along the lines that the untreated cells' mitotic rate is the same as the caffeinated cells' mitotic rate. So the first thing I did, I collected all my data. So these were the numbers or the values that I got when I went through the gizmo. I looked at 200 cells. 174 of them were in interphase. Okay? The rest of them are undergoing mitosis. So I had to add those up, and that total is 26. So I had 174 cells undergoing interphase and 26 undergoing mitosis. The next thing I'm going to need from this data in order to get my expected over here is a percentage. So of 200 cells, 174 of them were in interphase. That works out to be 87%. 26 of them are in mitosis. That works out to be 13%. And all I did was say 174 divided by 200, that gives me 87%. 26 divided by 200 gives me 13%. I'm going to use these percentages to figure out my expected. All right, now over here, this is your data table for your roots that were treated with caffeine. And if you add these up, you get 291. If you add these up, you get 6, and your total is 297. Now to do the chi-square work. So you got to think way back. It's been a while. You're going to make sort of a table. Or this is how I do it. I kind of do a little bit of a shortcut version. I'm going to start with my observed data. Up here it tells me that the control data will be expected. So my expected is over here. This is my observed. Okay? And I've got two categories, interphase, mitosis. So interphase, mitosis. My cells that were in interphase are 291. My cells that were mitotic are 6, and that's a total of 297. I'm going to need this number in just a minute. So this is where people started getting tripped up, I think. How do you figure out your expected? Your expected, the expected value is going to be based on the control data, which is over here. So if I had 297 cells that I observed after treating them with caffeine, how many would I expect there to be if I hadn't treated them? So let's go back over here. 87% should be in interphase. So I would take 0.87 times 297, and that is going to give me 258.4. What I expected based on my control data here, I expected those to be in mitosis to be 13% of the total. So 13% of 297 is 0.13 times 297. That gives me 38.6. So that's what I should have gotten if these cells were no different than the control. Your next step is to say O minus E squared divided by E. This is your expected. So I'm going to say O minus E, square it, and divide by E. When you do that, pretty sure because I did this math earlier, you get 4.11. So you can do that in a calculator and double check me or whatever. But you subtract these, square that, and then divide by this number here. That gives me a value for my interphase cells. Then you do the same thing for the mitosis cells. So you take 38.6 minus 6, square it, divide by the expected, and I got 27.53. So 27.53. Add those together. This is going to give you your chi-square value. Chi-square value is 31.64, give or take a little bit, depending on how you round or whatever. So this is my value. You're going to compare this value, your chi-square value, to the critical values table. So let me move this up. Here's your critical values table. Since we have two categories, if you remember, in order to get the degrees of freedom here, you take your two categories minus 1. If we'd have 5 categories, it would have been 5 minus 1. But we have 2, so our degrees of freedom are 1. We are looking for the 95% probability, or the 0.05%. So this is the certainty we are saying that we are calculating this to, is 0.05. Here's the critical value. So since my chi-square value is much greater than the critical value for 1 degree of freedom, I can reject the null hypothesis that there's no difference in the two sets of data, and I can make a claim about caffeine. According to my chi-square value and according to the data that I collected, I can safely say that caffeine lowers the rate of mitosis or decreases the rate of mitosis in these onion root tips, which is interesting because it's probably the opposite of what most people would have predicted. Since caffeine has kind of a excitatory effect on us, most of the time, and we've done this actual lab in class where we measure growth of the onion root tips instead of the mitosis. If you stick some onions in a solution that's got a whole bunch of caffeine in it, it really slows down the growth of those root tips. Caffeine has a inhibitory effect on the growth. So that's how you do the chi-square. I hope that helped clear that up. So you go back and apply that to your data. I checked a couple of yours who have already turned them in, and you need to go back and work on that chi-square.